Hello, good people, and welcome back. In this video, we are going to start with Unit 11, and Unit 11 is an introduction to binomial trees. And binomial trees are it's just a diagram, really, that captures the potential path that the stock price is going to take over the life of the option. And what we're going to do is use a method that we used in the last unit in order to derive, if you will, what the value of the option contracts are going to be. We're going to work with call and put option contracts, and we're going to make a couple of assumptions in the process of deriving those options. Now, on the slides, we have a lot of examples. We're going to be working those examples over on the board, and we have a lot of formulas, so we're going to be creating those formulas as we work on the examples. And my hope is that makes more sense than actually just going over the example all at once. So just like the last unit, I'm going to be spending a lot of time on the board and then come back to the slide just to summarize, if at all. So let's go back to the board, and this is what we're going to have. We're going to be working on the pricing of call options to start with. So we're going to work with call options. And the way we're going to go about this, at least the first method that we're going to use, is a method that we're going to call the no arbitrage method. And by now you understand what the concept of no arbitrage method is, because we've done that so often. We've used that over and over. And so what we're going to do here is the following. We're going to say our goal really is to say what is the price of that call option. What is that value? That's our goal. And we're trying to find what that value is. And if no arbitrage exists, that simply means that if the payoff of the call option is known, and we can create the portfolio that we can actually value, for which the payoff is exactly equal to the payoff of the call option, then that portfolio today should be worth as much as the call option is worth. And by that, what do I mean? Let's say that we have a stock today, and when that stock has a price S0, and that stock can either go up or down over a period of time T. If the stock goes up, it's going to go up by a factor that we're going to call U. And so when we multiply U by S0, which is the stock price, we get essentially the value of the stock price in the future. Let's call that S up. And if it goes down, it's going to go down by a factor of D. Let's write that well, D. And that's multiply D by S0. And we're going to get the value of the stock. If it goes down, let's call that stock D, which means stock down. That's what we have here for now. We have a call option on this stock with the strike price K. That call option is written today, so the payoff of the call option is going to be as follows. If the stock price does increase above K, the payoff of the call option is going to be equal to, remember, the payoff of the call option is the maximum of the stock price at expiration minus the strike price and 0. Now, if the stock price at expiration, and again, this would be expiration for us, that time, and this period here would be a period of time T. If the stock price at expiration is above the strike price, the payoff of the call option is going to be equal to stock up minus the strike price, right? That's the payoff, because stock up is assumed to be greater than the strike price, and we're going to call that call up. And if the stock price decreases, that is, if stock down is below the strike price, the option is not going to be exercised, so that payoff is going to be equal to 0, but then we're going to call that call down, right? That is, 0 here is true because we are assuming that stock down is less than the strike price. So you're not going to exercise the option and pay it for the stock at K where you could actually buy it in the open market for ST. So the option is not going to be exercised. It's going to expire out of the money. It's going to be having a value of 0. Now, if the stock price is greater than the strike price, you can buy at strike price and sell it at the stock price here and make a profit, which is why it's variable. Its outcome is equal to ST minus K, and ST in this case is S up. So that's what our call option is. And this is what we're trying to find. What is the price of this call option today? Now, we don't know how to value this call, but we do know how to value stocks and how to value bonds. So the question is, can we create a portfolio that has H stocks and some bonds? Let's call that, let's put a minus sign here, and some bonds, so that the future value of this portfolio, now we have H stocks. What does that mean? If the stock goes up, we're still going to have H stocks, but the price for each one of the stock is now going to be S up, right? Because now we are here and we're still working with a period of time T, so that is still T. We have H stocks. Each stock is worth now stock up, so the future value of just the stock component is going to be that. How about the future value of the bond? Well, the future value of the bond is going to be B future value. So that's what we have. We know how to value stocks and bond, so we're going to create a portfolio of stocks and bond, and we're going to look for the outcome of this portfolio over a period of time T. Now, if the stock goes up, we have H stocks, and each one was S0 before. Today, each one of the stock is now worth S up. We had a value of bond here. Its future value is simply the future value of that amount of money. If the stock price decreases, we have H stocks. Now the value is not stock down, so that's going to be S down. And the value of the bond is going to be the same, minus B future value. Now the question is, if we can find, we know what we know what S0 is. That's the stock price today. So that is known. If we can find H and B so that the future value of the portfolio is exactly equal to call up and call down, then this portfolio here is going to be equal to C. So if the portfolio has the same outcome as the call, then the price of the portfolio, which is this, is exactly equal to the value of the call option. And that's essentially what we're working with. And so the question is, how many stocks should I have in my portfolio, and how much bond should I have in a way that's going to make it such that the value of my portfolio is exactly equal to the value of the call option. Now, that is the idea of no arbitrage, right? Because if the outcome of this portfolio that we have here is not equal to the outcome of the call option, if the outcome of the portfolio is exactly equal to the outcome of the call option, and the value of the portfolio is not equal to the value of the call, then we have an arbitrage opportunity. And we're saying that there is no arbitrage opportunity that can exist in this environment. That's an assumption that we're making. And so to solve for H and B, what we're going to do is we're going to call this equation here 1, and we're going to call that equation here 2. And we're going to do 1 minus 2, and we're going to do the difference. Now, if we do 1 minus 2, what do we have? We have, I'm going to delete this, and we know that that's over a period of time T. We have H stock up minus H stuck down, that is this minus that, and then we can have b future value minus b future value. So that's really equal to b future value plus, because these two minus multiply each other, that becomes plus b future value. So these cancel each other. And at this point, what we have is call up minus call down. And so we can factor out h. So that's going to give us h stuck up minus stuck down is going to be equal to call up minus call down. And so h is going to be equal to call up minus call down divided by stuck up minus stuck down. And we're going to say that's the value of h here. We know what h is, so we're good. We have this first component. How about b? Well, if we know what h is, that means we can essentially plug back h in this first equation and solve for b. So what we're going to do is we're going to say that first equation was h is up minus b future value is equal to call up. So now we assume that we know h because that's what we have here. So minus b future value is going to be equal to call up minus h is up. And we multiply by minus 1, so b future value is going to be equal to h stuck up minus call up. And so b is going to be equal to h stuck up minus call up present value. And this is going to be b. So overall, we know that call value is going to be equal to h s0 plus minus b. It's not a plus, it's a minus. And that's true because we know that this is true, which means that we can substitute h there. So we're going to have call is going to be equal to h s0. We know what h is. Minus, what is b? b is h is up minus call up present value. And that is our call option price using binomial. Now I know this doesn't make too much sense, but we're going to work an example here in a second. But before we get to the example, let's look at what the slide has. So if we go back to the slide, and I'm going to skip all the examples that the slide has presented, and I'm just going to go all the way to the formula, the generalization. And with that generalization, all I'm going to look at is this last expression here. And in this last expression here, what we have really is the following. We have really is the call. I'm going to use something a little less. Is the call option value. So this is going to be our call option value is going to be equal to delta here is for us is h, right? So it's going to be 8. I'm going to write it up here. So it's going to get call value, that's f, is equal to S0 multiplied by delta. We're going to call delta is h for us. F is call. FU is call up. And SU is US0. And so F, which is our call price, that's what we have here, is going to be equal to S0, that's S0. Delta, we said delta is H, so we're going to say H minus, that's the minus here, S0 multiplied by U, that's S up, so we're going to say S up here. That's S0 multiplied by U. Delta, again, remember that delta is H multiplied by H minus, so that's a minus. FU, we say that as call up, so that's going to be call up. And then when we close that, we say present value, present value. So let's arrange this. This is essentially equal to, I'm going to have a slightly invasive, call is going to be equal to H stock 0. All I did is switch that over, minus H stock up minus call up present value. And that's exactly what we have on our board when we have H is 0 minus H is up, call up, present value. That's where that expression comes from. It comes from the assumption that we don't know how to value the call, but we know how to value stocks and bonds. So if we create a portfolio of stocks and bonds, the portfolio is going to have H stocks and some bonds. The future value of that portfolio is going to be the future value of the stocks multiplied by the number of stocks that we have and the future value of the bond. If that future value of the portfolio is equal to call up here, and the future value of the portfolio, if the stock price decreases, is equal to call down, all what that means is that the value of the portfolio today is exactly equal to the value of the call option. And so if we did that, then we can find what H is, that is how many stocks we should have in that portfolio for every bond that we are trying to create. And H is also what we refer to as the delta of the option. And it's also what we refer to as the hedge ratio. And that's why I'm using H here for hedge ratio versus using delta. You could use delta there, and that's why we call the H here delta as well. So I use H for hedge, or you could use delta for delta. Once we have H, we can substitute back H in equation 1. So this was equation 1. And equation 1 was this that we had here. And we solve for B. Now, when we put things back together, this is what we have. Let's work an example of this really quick. An example of that we're going to work is the one that we have on the slides. So on the slides, this is what we have. We have a stock that is currently priced at $20. So S0 is going to be equal to $20. Over a period of time T, that's equal to 3 months. What we have is a future price of the stock that we cannot know. We still know that that future price is going to be S up. And that future price, apparently, we've done some computation and we found that that future price is going to be equal to $22. So that future price is going to be $22 if it goes up. And if it goes down, stock down, we know that that future price is going to be at $18. And the call option that is written on this stock has a strike price K that's equal to 21. And what we have asked to find is what is the price of that call option. Well, this is what we have. We said that if we have H stocks plus minus some bonds, and we said that the future value of this is going to be equal to H stock up minus bond future value, and here we're going to have H stock down minus bond future value. And we said that if this here is equal to call up and that here is equal to call down, then this here is going to be equal to the call option value. So we're going to set that to be true, and what we're going to do to find our call value is to find what H is and what B is, because we know what S0 is and this is S0. Now we just showed that in this case H is going to be equal to call up minus call down divided by stock up minus stock down. Now what is call up? Call up is going to be the maximum of the stock price minus strike price. So it's going to be S up minus K, and call down is also going to be SD minus K. Alright, so what is call up? Is stock up is 22 minus strike price 21, which is 21, which means that call up is equal to 1. Call down is going to be equal to S down minus the strike price, so that's going to be equal to stock down, which is 18, that's stock down, minus the strike price, which is 21, and that is equal to minus 3. Now we remember our payoff is always the maximum of ST minus K and 0. In this case, ST minus K is equal to 1, so we're going to keep that at 1. The maximum between 1 and 0 is 1. And in this case, ST minus K is equal to minus 3, so the maximum between minus 3 and 0 is 0. We're going to ignore this, so we're going to say this is going to be equal to, that was minus 3, so we're going to cancel that. We're going to say it's equal to 0. So our call down is going to be equal to 0. What is our H then? Is going to be equal to call up, which is 1 minus call down, which is 0, divided by stock up, which is 22, minus stock down, which is 18. So we're going to have 1 divided by 4, and that gives us 0.25. So H for us, you remember the notes there said delta, so delta, which is equal to H, is equal to 0.25. That is going to be our first outcome here. Now, we also said if we know what H is, we can essentially plug it back in here and try to solve for B. So what is B? B, it turns out, is equal to H S up minus call up present value. Now, the interest rate we given there is equal to, let me see, interest rate R is equal to 12% per year. So B is going to be equal to, we know what H is, 0.25, so 0.25 multiplied by S up, and S up is equal to 22, minus call up, we just found that call up is equal to 1, and then we take the present value of that, that is exponential of minus 12%, and T is going to be equal to 3 months, and 3 months is 1/4. So what that's going to give us is the following. We're going to pull our calculator, and we're going to say 0.12 minus divided by 4 equal, and then we take the exponential of that, second function exponential, and we're going to store that 1. So store that 1. Next, what we're going to do is 22 multiplied by 0.25, that's equal to 5.5, minus 1, that's equal to 4.5, and we're going to multiply that by what we stored. So we're going to multiply this value here by recall 1 equal. So that's going to be 4.36. So B is going to be equal to 4.367. So B is going to be equal to 4.367. That's going to be B for us. So what is our stock price? Our stock price, our call price, I should say, is equal to H S0 minus B, which is equal to H is 0.25, S0 is 20, minus B, which is 4.367. So that gives us 5, that is 0.25 multiplied by 20, that's 1/4 of 20, that's 5, minus 4.367. So that gives us, minus here, plus 5, 0.6329, 0.633. So B is equal to 0.6, call value is 0.633, and that would be our call price. Now, if we wanted to apply the formula all at once, what would we have? Well, our formula all at once was the following. It was call price is equal to H S0 minus H stock up minus call up present value. That would be equal to 1/4, which is 0.25, multiplied by 20 minus 1/4, which is 0.25, multiplied by 22 minus the call up, which is 1, and then present value minus 12%, 1/4. And this should give you exactly what we have here, which is 0.633. And that would be our call option price. Now let's go back to the slides here and see what we have there. Well, in the example that we have on the slides, which is the very first next slide, we have an example where we're working with a stock price that's at 20. A 3 months, we are assuming that the stock price is going to be either 22 or 18. So that's today's price, and this is what we call S0, and this is what we call S up, and that's called S down. And the value of the option contract of the delta in this case, we found that to be equal to 0.25, and that for us was equal to call up minus call down divided by stock up minus stock down, which is essentially what they did here, where they equalized this, right? So if we say 22 multiplied by delta minus 1 is equal to 18 delta. What that means is 22 delta minus 18 delta is going to be equal to 1, which means that delta multiplied by 22 minus 18 is equal to 1. And that means that delta is going to be equal to 1 divided by 22 minus 18. Now, 22 is S up, 18 is S down, 1 is call up, and we know that call down is 0. And that's exactly the same that we have here. So the delta that we have is at 0.25. Alright, with the delta equal to 0.25, what we do is we solve for the present value of the outcome, and what we obtain is the following. We obtain essentially 0.633, which is the option value. And what we have here is a long position in 0.25 shares of stocks and a short 1 option. What we did there is we didn't essentially use the option as the second element in our expression. What we said is we used stocks and bonds. And that is the approach. And in the generalization here, what we essentially have is delta, which is equal to call up minus call down divided by stock up minus stock down. Now the idea here is that the stock grows by a factor of U if it increases, and the stock decreases by a factor of D. And so what we have here is the equivalent of call up minus call down divided by stock up minus stock down. One of the reasons I move away from this expression and I rather use the C up, CD, and S up and SD is because I think it's a little more intuitive. Usually my students have a problem looking at it that way, so I try to move away from that expression. Alright, so this is what we're going to have for a call option, and I hope that this makes sense. This example clarifies things a little bit for you. We could do the same thing for a put option. This was our example for a call. Let's try to do that for a put. Well, if we did that for a put, remember we constructed a portfolio of stocks and bonds so that the outcome of the portfolio is exactly equal to the outcome of the put option, and therefore the value of the portfolio is equal to the value of the put option. So what are we going to have? We're going to have H stocks minus bonds. That is going to have an outcome of H stock up minus bond future value, and H stock down minus bond future value. That's going to be equal to put up, and this is going to be equal to put down, and if that is true, this is equal to the put option value. And again, what we're going to do, we're going to put a minus sign here and do 1 minus 2. If we do 1 minus 2, what are we going to have? We're going to have the same scenario. Actually, let's do 2 minus 1 for the put option. The payoff for the put option is going to be the following. If the stock price increases, we're going to have, anyway, for the put option, it's going to maximum of strike price minus stock up and 0. And here we're going to have the maximum of strike price minus stock down and 0. And let's do 2 minus 1. So 2 minus 1 is essentially going to say H stock down minus H stock up. And then we can have B future value minus B future value. So these are going to cancel each other also, and we're going to be left with put down minus put up. And so from here we can say H stock down minus stock up is equal to put down minus put up, which means that H is equal to put down minus put up divided by stock down minus stock up. Now you could also write it the exact same way as we had earlier, right? Where we had put up minus put down divided by stock up minus stock down. You're gonna have the same thing. The outcome is gonna be exactly the same. In this case, I'm using the opposite just to show you that it works either way. I didn't choose to do 1 minus 2. You could also do 2 minus 1. You would have the same thing. Now, we know H now, so let's plug H in 2, right? In the last time we plugged H in 1, so in this case let's plug H in 2, just to show that we get the same thing. What we're going to have in this case is going to be the following. We're going to have H that we now know, stock down minus B future value, is going to be equal to put down, because we are plugging now in equation 2, which means that minus B future value is going to be equal to put down minus H stock down, which means that B future value is going to be equal to H stock down minus put down, which means that B is going to be equal to H stock down minus put down present value. So ultimately what we're going to have is our put option price, which is equal to H S0 minus B. That's what we have here. And so our put option price is going to be equal to H that we have, S0 that we have, minus H stock down minus put down, and then we're going to take the present value of that. And that would be our put option price. Now let's work this with the same data that we had in the last example. In that last example, what we had was the following. Stock 0 was 20. Stock up was 22. Stock down was 18. Let me use a different color here just to make sure that I am consistent. S0 was 20, S up was 22, S down was 18, and then what we had was the strike price was at 21, and we also had the interest rate, which is at 12%. So what do we have? Stock 0 can be either S up or S down, and we are working with a put option, and our put option can be either the strike price minus stock up, or strike price minus stock down, and 0. So that's the maximum of this value or the maximum of that value. So if we apply this, what do we have? Remember, we're working with the maximum here. If we apply that, this is what we're going to have. H stock 0 minus bond, which is equal to the put option price, is going to have the following outcome. It's going to have H stock up minus the value of the bond, future value. That's going to be equal to our put up. Now, what is the put up? It's the maximum of the strike price minus stock up. Stock up is going to be equal to the strike price at 21, so it's going to be 21 minus stock up 22 and 0. 21 minus 22, that is equal to minus 1 and 0. And remember, we're taking the maximum, so this is going to be equal to 0. Our put up is going to be equal to 0. If the stock price decreases, we're going to have H stock down minus B future value, and that's going to be equal to put down. And our put down is, again, strike price minus stock down, which is 21, minus stock down, which is 18, and 0. 21 minus 18, that is going to be equal to 3, right? So that's going to be 2, 3, so this is going to be equal to 3. Which means that between 3 and 0, our put down is going to be equal to 3. So in this case, we know what put up is equal to 0 and put down is equal to 3. So our hedge ratio, or H, is going to be equal to put down minus put up divided by stock down minus stock up, which is equal to 3 minus 0 divided by stock down 18 minus stock up 22. So our hedge ratio is going to be equal to 3 divided by 1822. That's going to be 2 plus 2, 4, 3/4. Now, remember the 18 minus 22, that's actually negative, so we're going to have a minus sign here. And that's going to be our hedge ratio. And next, what we're going to look at is B. B, we found out, was equal to H stock down minus put down, and then we took the present value of that. So B is going to be equal to minus 3/4 multiplied by stock down, which is 18, minus put down, and put down, you remember, was 3 minus 3, and then we take the present value of that at 12%, and remember T remains the same. T is 1/4 because it's 3 months, so minus 12% divided by 4. And so let's pull our financial calculator and do just that. 0.12, which is our 12%, divided by 4 equal minus second function exponential. Let's store that 1, and what we're going to do is 3 divided by 4 equal minus multiplied by 18 equal, that's the first term there, minus 3 equal, that gives us minus 16.5, and then we're going to multiply that by what we stored, so multiply that by recall 1 equal, that gives us minus 16.012, so B is going to be equal to minus 16.012 about. Now our put option price is going to be equal to H S0 minus B, which is going to be equal to minus 3/4 of S0, which is equal to 20, and then we're going to subtract that to B, which means that we're going to do minus, and B is negative, remember, so that's going to be minus 16.012. So it's going to be equal to minus 3/4 of 20 plus 16.012 about. Now what we are going to have is the following: minus 3/4 of 20, 3/4 is 75%, 75% times 20 as 15, so minus 15 plus 16.012. And I remember I didn't get rid of the decimal here, so all I'm going to do is I'm going to add 15 to that equal, and so if I add 15 to that, yes, I kept the sign there, so I'm going to have 1.012. Well, remember, this is what we're going to have: 15 minus plus 16.012, and that's going to give us 1.012. And so our put option price is going to be equal to $1.012. That would be the same principle that we apply to find our put option value. Now remember, so far we are working with the European options. Now we know how to value a call option using our binomial tree. That's the binomial tree because we are assuming two possible outcomes, right? So it's binomial. We know that we can find the hedge ratio, and we infer from the hedge ratio what the the B there is going to be, which is that value here, and from there we can find what the put option price is going to be. So we have our put option value expression, which is that for the put, and we have our put option value expression, our call option value expression, which is essentially this for the call. And we know what H is call up minus call down divided by stock up minus stock down. And here we know what here we also know what H is. H for the put is equal to put down minus put up divided by stock down minus stock up. Now, something you want to note as well is that when we were working with the call, we found out the H for the call, or the hedge ratio for the call, was a positive value. So hedge ratio for the call is positive, and when we are working with a put, we found that the hedge ratio for the put is negative. So the H for the put, the hedge ratio for the put, is going to be negative, which means that the stock that we're going to have is going to be shorted. So we're going to short the stock there, and for a portfolio to find the value of the call, we're going to take a long position because H is going to be positive, right? We're going to take a long position in stock. So you could do long stock here, and then some bonds, and on the other hand we do short stocks and some bond for the put option. Now remember, if you're investing in put option, you believe that the stock price is going to be decreasing, so that makes sense. If you're investing in call option, you believe in the stock price is going to be increasing, so you may want to take a long position in the stock, so that also makes sense. Alright, so these are going to be call and put using that method that we describe as the no arbitrage method. If we are to use an alternative method, what would that alternative method essentially be? Well, let's assume that we are living in a world that is essentially risk neutral. So we are using the risk neutral proposition. And under the risk neutral proposition, the return that we are earning on our investment, on any investment, is going to be the risk-free rate of return. And so if we earn the risk-free rate of return, it means that a stock that we purchase today is going to have a future value that's exactly equal to the future value of the stock at the risk-free rate of return, right? So this is how much we earn on our investment, and therefore the future value of the stock is going to be equal to the future value of the stock, or the expected future value of the stock is nothing else but the value of the stock that grows at the risk-free rate of return. That is our risk neutral proposition there. And what we're going to say with this risk neutral proposition is that that also holds for our portfolio of stocks, the outcome of our bond portfolio, if you will. And by that, what do we mean? Well, we really don't know what the future value of the stock is going to be, right? So if we use binomial, what we say is that we have a stock today that can either go up or go down in value, and if it goes up, it's going to go up by it's going to go up to S up. If it goes down, it's going to go down to S down. Now we could also say that if we're living in a risk neutral world, and we can estimate what we refer to as risk neutral probabilities, P and Q, which are risk neutral probabilities, that the stock price is actually going to go from S0 to S up, and that the stock price is actually going to go from S0 to S down. What that means is the future value of this bond portfolio of this portfolio, I'm sorry, not bond portfolio, the stock here is essentially going to be equal to the weighted average of the outcomes. So the future value, which is S0 future value, is essentially going to be equal to the probability that the stock price increases, that we call that P, multiplied by S up, plus the probability that the stock price decreases, which is Q, and we call that Q, multiplied by stock down. So P and Q are just probabilities, risk neutral probabilities, because we live in a risk neutral world, that the stock price is going to be increasing from S0 to S up, and Q is the risk neutral probability that the stock price is going to decrease from S0 to S down. If we are risk neutral, this is what we should have in the future. And then what that also means is that if we know the probabilities, this outcome is going to be equal to a weighted average of the outcomes given the probabilities. Now, if the stock doesn't go up, it means that it's gone down essentially under that argument. And so we're going to say that Q here is exactly equal to 1 minus P. So what we're going to have is the following: the stock price is going to, future value is really going to be equal to P, which is the risk neutral probability that the stock price is going to be increasing, multiplied by S up, plus Q. Remember, Q is 1 minus P, so we're going to say 1 minus P, which is Q, multiplied by stock down. And if that is true, we can find what the stock price today should be worth. And so S0 should essentially be equal to the present value of that. So PS up plus 1 minus P stock down. And then we do the present value. Now, if this works for a stock, it should work for a call. So in the risk neutral world, what we're going to have is a call option that can either have a positive outcome or an outcome that's lower. So we can have call up or call down. And in that risk neutral world, if we have the probabilities P that the stock price is going to be increasing, which means that we're going to have call up, and we have a probability Q that the stock price is going to be decreasing, which means we're going to have call down, the outcome of this call option is essentially going to be equal to P call up plus 1 minus P call down. That's going to be equal to our call option value, future value in the risk neutral world. And so our call option value here is simply going to be equal to P call up plus 1 minus P call down present value. And this is how you would approach this under the risk neutral proposition. And you would do the same thing for a put, right? For the put option value, what you would essentially do is we have a put option, can either go up to put up, and if the stock price increases, to put down. And so our put option value is essentially going to be equal to P probability up multiplied by put up plus 1 minus P multiplied by put down, and then we take the present value. Now we want to be careful here to know that this is a put option price, and that here is a probability, and this here is a probability. Okay, and here we are working with the probability, and here we are working with the probability. Now the question is, how do we estimate that risk neutral probability? Well, it turns out that, I'm not going to derive this, but it turns out that that probability P is actually equal to the future value of $1 minus D divided by U minus D. And U is going to be equal to S up divided by S0, and D is going to be equal to stock down divided by S0. If we want to account for volatility of the option, U can essentially be rewritten or expressed as a function of the volatility of the option. And if we did that, what we would find is that U is essentially equal to, I'm going to delete this, the exponential of the standard deviation multiplied by the square root of t, and D is essentially equal to the exponential of minus standard deviation square root of t. Now, in this case, what you can find is that U is equal to 1 over D, and D is equal to 1 over U. That is when we want to account for to match the probabilities to the period. Now this is what we're going to use here in our example, and I know this might look confusing, but it's actually really simple if you work with that and with an example. And so let's do the same thing for our example here. In the example that we had with the call, remember we had S0, which was 20, S up, which was 22, S down, which was 18, and we had the strike price, which was 21. We had interest rate that was 12%, and T was 3 months, so 1/4, which was 3 months. Early on, what we were able to find is the value of the call. Where was that? The value of our call option was equal to 0.633. That's the value of our call. So what we can do is we can see our call value is going to be equal to 0.633, and that's what we need to verify. Now, in our risk neutral world, this is what we have. We have a scenario where we say that a call option is going to be equal to the probability weighted of the outcome, so P call up plus P1 minus P call down present value. This is actually really simple. We know that P is equal to, which is the probability, remember these are probabilities, the future value of $1 at the interest rate, which is the risk-free, minus D divided by U minus D, and we know that U is equal to S up divided by S0, and we know that D is equal to S down divided by S0. So U is going to be equal to 22 divided by 20, and D is going to be equal to 18 divided by 20. So what do we have? U is going to be equal to, what's 22 divided by 20 is 1.1, right? So 22 divided by 20, that's 1.1, and D is going to be equal to 18 divided by 20, 19%. There we go, 0.9. That's going to be U, and that's going to be D. So P, which is our probability here, is going to be equal to the exponential of the interest rate, which is 12%. So that's going to be 0.12 multiplied by 1/4, because that's T, minus D, which is 0.9, divided by U, 1.1, minus D, 0.9. Alright, so let's do this. 0.12 divided by 4, second function exponential, minus 0.9 equal, we're going to divide that by, open parenthesis, 1.1 minus 0.9 close parenthesis, equal. So our probability that the stock price, our risk neutral probability that the stock price is going to be increasing is equal to 0.6522. That's going to be our probability that the stock price is going to be increasing. So we're going to say equal to 0.6, what was that? 6522. 6522. That's going to be our P. Actually, I'm going to call that probability up, which means that Q, which is equal to 1 minus P, is going to be equal to 1 minus 0.6522. So I'm going to do this, minus plus 1 equal 0.3477. So we're going to have 0.3477, and that's going to be probability down. And what we said is that we have to find the call option value is going to be probability up multiplied by call up plus probability down multiplied by call down present value. And so call up, remember, is equal to stock up minus strike price, which is equal to 22 minus 21, which is equal to 1. And call down is going to be equal to stock down minus strike price, or 0, remember, is the maximum of the two. And so we're going to have stock down, which is 18, minus strike price, which is 21. That gives us minus 3, but we cannot use that because we're taking the maximum of this, so call down is actually going to be equal to 0. And this is the same that we had earlier. So our call option value is going to be equal to probability up 0.6522 multiplied by call up, which is 1, plus probability down, which is 0. I'm going to use a different color here just to make sure that we see clearly, multiplied by 1, and then we're going to say plus the probability that the stock price decreases, which is 0.3477, that we multiplied again by call down, which is 0. So we're going to multiply that by 0. And then we're going to take the present value of that at the risk-free rate of return, which is 12%, divided by 4, multiplied by 1/4. Alright, so what do we have? The call is going to be equal to essentially this. That here is going to be equal to 0, so we can essentially cancel that. And this value multiplied by 1 is just that. So it's going to be equal to 0.6522 multiplied by the present value, which is minus 12%, divided by 4. And when that is going to be equal to 0.12 divided by 4 equal minus second function exponential. That gives us that, and we're going to multiply that by 0.6522 equal. What we're going to have is 0.6329 or 0.633. 0.633. So our call option value is going to be equal to 0.633. Which is exactly equal to what we had earlier. Remember, we said we wanted to verify this. That's exactly equal to what we had earlier, 0.633. So there are two ways to varying options. Essentially, you could use this risk neutral assumption. If you use the risk neutral assumption, this is what you're using, where P is the probability that the stock price increases, and how you find P, this is how you find P. And for the put option, you would essentially do the same thing. We're not going to work the example of the put here, but you would apply the same concept. You find P the same manner, so we use the same P, and then we use put up and put down, and then we have the probabilities. Actually, we have P, so we could just do that. So for the put, what do we have? We're going to have P put up plus 1 minus P put down, and then present value, and that will give us our put option price. So put up is going to be equal to 0, you remember that, so that's going to be equal to 0 plus the 1 minus P was 0.3477 multiplied by put down. What was put down again? Put down was 3 multiplied by 3, and then we do present value, which is minus 12% divided by 4. So essentially what do we have? We have 0.12 divided by 4 equal minus second function exponential, and then we're going to multiply that by 3, and then we're going to multiply that again by 0.3477, and what we're going to have is 1.012. So our put option value is going to be equal to 1.012. And so we can go back up here, and we can see that all the way up here, when we're working with that example, we found a put option value equal to 1.012. And so here we find our put option value equal to 1.012, which is exactly equal to the same thing. Okay, so that's going to be our risk neutral approach, and also our no arbitrage method of valuing a call option and a put option. Now, before I stop the video, what I want to do is go back to the slides and show what we have. So the generalization here is essentially saying that you have a risk neutral probability multiplied by call up plus a 1 minus the risk neutral probability, which is Q, multiplied by call down, present value, where P, which is that probability, is equal to the future value of the law minus D, U minus D. Same thing that we did there. And if we did that, we would essentially replicate the value of a put option price, of a call option price. This is for a call. This is for a call. And you could do the same for a put. So for a put, what you would have is P put up plus 1 minus P put down, and you would have present value. So the same thing. Now P there is exactly what we use for the call, right? That doesn't change for a call or put. What that represents is the risk neutral probability that the stock price can be increasing over that period, or that, and Y minus P would be the risk neutral probability that the stock price can be decreasing over that same period. And that is essentially what we have here when we say P is going to be showing that increase, Q is going to be showing that decrease, and we're looking at the risk neutral valuation, where if we assume those risk neutral probability of up and down movement like equal to P and Y minus P, the expected stock price is equal to the future value of the stock price, and when we set that equal to the weighted average of the values of the stock at that point in time, that's how we infer that option contract's value. And so we work that example, and when we work that example, in this case using the risk neutral probability, we find that, and using 0.652, that's just the same problem that we had here, 1.1, 0.9. We have a call option price, because this is still for the call. we had a call option price essentially equal to 0.633, which was exactly what we had earlier. And now you remember that this second component here was equal to 0, so we essentially cancel that for the call, and you could do the same thing for the put. Alright, so this is a good time to stop. I'm going to stop here. When I'm going to come back in the next video, we're going to do that for 2 steps. And the 2 steps is going to be really easy because we know what the 1 step is with the risk neutral probabilities. And once we have the risk neutral probabilities, it makes life way too easy. Alright, I'll see you in the next video for just that.